Hi, Mick McQuaid here. I'd like to show you how I'd like you to do homework 1 using exercise 2.4.9 as an example. So I'm in the RStudio interface, and I'm going to create a new file, and that file is going to be an R Markdown file, and I'm just going to call it 0. And I'm going to say I want it to output to PDF. And this didn't come out exactly the way I wanted it to. This should have some indentation and more indentation here. Okay, and then it gave me a sample R Markdown document. You can just use this to see what R Markdown is supposed to look like. It's worthwhile to include some of this kind of stuff usually. I'm not going to include it in this one. I'm just going to delete the whole thing for now. You can use it as a kind of a dry run thing to make sure that your system is working. But I know my system is working, so I don't need the dry run. There are a couple of bugs. There are a couple of problems, so it's not going to work perfectly. So I just did this. I just ran this and was unsuccessful at some of it. So bear with me as I try to work through this. Okay, so the first thing I want to do is copy and paste all the questions here. By the way, I guess the first thing that I did was initialize the document. This header is in the format known as yet another markup language, or YAML. And YAML, I guess it's actually called YAML ain't a markup language, or something like that. I forget what it stands for, but anyway, it's YAML, YAML, and the spacing here is significant. There has to be a space after the colons, and the indentation is significant, and so keep that in mind. So this, when you render this document, this is going to be a lot of metadata you can include in the document. Okay, and then I'm going to put a blank line between each of these. I'm going to put a lot of blank lines in here. And I'm going to do some initialization here. So I'm going to put a code fence. So this is going to create an R chunk. I'll call it setup. And I'm going to load the ISLR package. If you already have the ISLR package, you can do this. If you don't already have it, you should install it. And one way you could install it would be to do this. You do that. And I'm not going to run that because I already have it. If you install it in what I see a lot of students doing is installing in the document, and then what happens is it installs every time you run the document, which you don't want. So I'm going to do the let's see, library statement, and then what else do I need here? I've got a cheat sheet here from when I did this before. Oh, okay, so I want the auto data. And I'm going to, against all good advice, I'm going to attach auto. And I'm going to take a look at the structure of auto. And I'm going to take a look at the number of rows in row auto and the number of columns in auto. By the way, in RStudio, I have under preferences, I've gone to code, and under code I've changed key bindings to Vim. So that's just a faster way for me to edit, is using Vim. So you don't have to do that. But it may explain why sometimes the cursor seems to jump around a little bit. Okay, and then I'm going to say nrow and auto again. And the reason that I'm going to do that is I want to know if this had any effect on the number of rows and the number of columns. So this is an assignment statement. I'm assigning the output of the function na.omit run on auto to the auto object, so that the auto object now has all the missing values removed. So that's just taking care of what it says to do in this sentence right here. And then I want to know what the names of the columns are. So I'm just going to say call names auto. And then I want to know which of the predictors, let's see. Oh, one thing I'm going to do here before I start on part A is I'm going to say with auto. So it's just saying with that data set, I'm going to say cylinders as factor cylinders. So that's going to cause the cylinders variable to be interpreted as a factor. And then I just put a code fence at the end. A lot of times it's better to put the code fence that's going to go at the end right when you start it. So I'm just going to do that here. In fact, what am I going to call? Just call this 0. In fact, what I want to do is I'm going to do this for all of them, because all of them except the last one well, that doesn't work very well. All of them except for F are going to require some code. There should have been a blank line after, I don't know. And then I'm going to change all these labels are necessary. They help you keep track of what you're doing when you actually render the document. And the labels, it'll actually stop execution if the labels are the same. The labels have to be unique. And the labels probably shouldn't have any spaces in their names. It's actually, you can run into problems if you have spaces in the names. Not necessarily, but you can. Okay, so which of the predictors are quantitative and which are qualitative? So I can say summary auto. And I can remove this hyphen if I want. I can remove this hyphen if I want. Okay, and then summary auto is going to give us the output that's going to tell us which are quantitative, and what we're going to find if we run this is quantitative is miles per gallon, displacement, horsepower, weight, acceleration, and year. And by the way, I can run this at any time. I'm just doing that off the cheat sheet. I can run this by going knit to PDF. Now, have I actually written this file? Yeah. So I think the fact that it was in red signified that there were unsaved changes. So I'm going to say knit to PDF and see what happens. And it takes a minute. So I can see the structure of the file here, the auto data file, dataset, and I get the summary here. Okay, and that told me that that was quantitative, and qualitative are cylinders. This is just my idea of what's quantitative. Qualitative. The textbook may tell you that cylinders is quantitative, but we're not using any quantitative information. For example, 4 cylinders is half as many as 8 cylinders. We're not really using that fact in this. So we're not treating them as anything other than nominal. Okay, what is the range of each quantitative predictor? You can answer this using the range function. Okay, so we are done with part A. So part B, I can say range. Okay, so I can do something that's fairly boring here. I can do range MPG, and then range displacement, and so on. I could do that for all of them, but a faster way, if you know it, is to use the sapply function. And I'm going to use the sapply function only on well, let me actually, just for pedagogical reasons, let me do it. I'm just going to run this. So you can run a chunk. This isn't always a good idea, running individual chunks. But I'm going to run these chunks here. And this chunk is going to give me an error message that says that range is not meaningful for factors. So cylinders is a factor, and range is not a meaningful function on a factor. So I need to take a subset of the columns. I want to get rid of column 2. So I'm going to index. So these square brackets are indexing this kind of rectangle. You can think of the auto data set as a big rectangle with rows and columns, and I'm going to take all the rows, so I'm going to leave the rows part blank. So before the comma is rows and after the comma is columns. So I'd like to do column 1 and column 3 through 7 here. Unfortunately, because this is not a contiguous range, this comma is going to get in the way. So what I need to do is say C So this C function will concatenate or combine, or whatever C stands for, these columns. So now if I run this, I get an actual result. Okay, so what is the mean and standard deviation of each? So was that all that was asked here? Yeah. Okay, what is the mean and standard deviation? So I could do that same thing. I can go, let me copy this line here and put it here, and instead of range I can say mean, and instead of mean I can say standard deviation. Oops. Okay, so I can do that, but the output is going to be kind of ugly looking. See how, to me that's ugly anyway. So I can do a different way that will look a little bit better. The output will look better. The input looks horrendous. So the output's going to be a data frame. So the output is going to be like a kind of a rectangular table. And it's going to be transposed. And I'm going to do this same thing, sapply. But I'm going to do it with a number of functions instead of a single function. So I'm going to say sapply auto, the same indexing business that we did before. Now if I can figure my way out of these nested parentheses, I'm going to say function blah. Blah is just a placeholder. and then I'm going to say list means. Okay, and so now is where I'm getting the body of the table. The means in the table are going to be mean of blah, and I just made up the name means. The name mean is meaningful to R, but means is just a variable name that I've assigned because I want the table to say means. Okay, and then SDS equals SD blah. Again, I made up SDS as a variable name. Ranges I made up as a variable name, but range and SD are okay. Now this should work except for one problem. Okay, this isn't displaying right. So this is telling me what's in there, that it's what's in there is a double, a single double. That's a kind of floating point number, and this is two doubles. But it's not actually showing me the numbers. So I'm going to knit so that it will show me the numbers. Show me the numbers. And when I knit it, it shows me the numbers. So this is what I'm looking for, is this kind of rectangular display here, this kind of table. And we can actually beautify this table even more than this. So this table is at least more or less readable, but we could make these headings in bold or italics and put a little line in between the heading and the body and all kinds of stuff like that, but I'm not going to bother with that right now. I'm just going to continue on. Okay, so that was the only thing we needed to do for that. Now remove the 10th through 85th observations, and it asks the same question, but about this subset. So what we can do is just copy what we just did. Is this one line? Yeah. Okay, so I'm just going to copy that line here, and now I want to take a subset of the rows just as I took a subset of the columns. So I want to take minus 10 colon minus 85, and you may wonder why I didn't have to say C, and that's because these are contiguous. So because these are contiguous, there's no comma in here, so it's not going to confuse the indexing function. Okay, and I'll have the same problem when I do that. It'll display like this when I just display it. I'll have to render again. Let me make sure I've written this file, and then I'll render to PDF. And now I should have two of these tables. So I have one for the whole data set and one for the subset data set. And the subset data set has a smaller range, you'll notice, for some of these than the original data set. And of course that's just a common sense thing. And you should always be checking your work for common sense indicators that things are going well. So the range should be either the same or smaller in the subset than it was in the, because we're just removing stuff, we're not adding stuff. But the standard deviation could be larger in the subset, because we might be removing outliers, or we might be removing things near the mean, so the standard deviation gets larger, or removing outliers so the standard deviation gets smaller. And likewise, the mean should be different. Okay, so that's a compact way to show a lot of information. Okay, now using the full data set, investigate the predictors graphically. So I'm going to do this in a very simplistic way, and this may not work for you. So let me just show you the output of this. The result of this is a scatter plot matrix. The pairs function gives you a scatter plot matrix of all the pairs of variables. And the reason that I say that this might not work for you is that it's very tiny here. So on my display, so I have another display. So what I'm just showing you on this screen is a very small part of my display. I actually have a display that's large enough to display this scatter plot matrix in a reasonable size so that I can distinguish what's going on in every one of these little windows. So if you don't have that, if you don't have a large display, it may make sense to do things like create create individual plots. So see, if I run this now, I'm going to get a this plot right here, horsepower and displacement, is this right here. It's exactly the same thing, except that it's blown up so that we can make out the details better. So now I'm supposed to also, so I'm supposed to create some plots. So that scatter plot matrix tells me enough. You may need to do scatter plots between the other pairs of predictors. And then it says comment on your findings. So I have a comment that I wrote previously, and I'm just going to copy it in here. It's a long comment, so I want to write this comment in because I want you to understand that your comments shouldn't be too terse. And a somewhat strong this somewhat strong, not a somewhat strongest, what am I saying? What else do I want to say here? So a lot of computing is just typing. So learn to type and type out a lot of stuff here and make it meaningful stuff. So there's a balance that you have to achieve between saying too little and saying too much. And this, to me, represents a good balance here. It convinces me that the person who wrote it really looked at the plots and understood what was going on in them. And you shouldn't just copy what I'm saying. You should actually go through the plots yourself and figure out whether you think there's a strong categorical relationship between displacement and cylinders, and why do you think that that's the case. Okay, and then this last question is just verbiage. I can answer this question on the basis of the scatter plot matrix that I just created. So I want to predict gas mileage on the basis of the other variables. So if I go back to this scatter plot matrix here and I just look across the top row here, I can tell what are the best predictors. And basically the best predictors are these three, and let's see, displacement, horsepower, weight. I think, yeah, it's basically those. And weight is the best. So if we expand these three plots here, you should see that the relationship with weight has fewer outliers than the relationships with displacement and horsepower, and that will make you say weight. And notice that I say it appears to be, so that's kind of a weasel wording that is common in statistics, and we do that weasel wording because we know that there might be evidence that's not available or that we haven't considered yet that might contradict it. So this is just based on what we know so far. Weight is the best predictor. Weight appears to be the best predictor. So this is a really old data set. Only two 3,500 pound plus cars get better than 20 miles per gallon. Nowadays, you know, every car gets better than 20 miles per gallon. Cars are just much better today. But for this data set, this is what we're seeing. And displacement and horsepower have some outliers at the low end, but fewer outliers at the high end. So I'm going to say something about that. And I'm done. So I'm just going to let me just write this file and knit to PDF. Oops, did I knit to PDF? Yes. So if I do this little triangle here, I can specify PDF, but if I just knit, it'll go to whatever is the default, and I guess I set the default to be PDF. So I just take a quick look at this. It looks okay. It's not the most exciting looking document, but it's not awful. You could certainly add more plots if you want. This scatter plot matrix is really kind of tiny, kind of difficult to read. You could actually create a couple of scatter plot matrices, since you know that miles per gallon has this somewhat curved relationship here. That gives you an idea that you might want to do a scatter plot matrix just of this amount: miles per gallon, cylinders, displacement, horsepower, and weight. You definitely can get rid of name and origin. Name is meaningless. Origin is, you can see that there's a little bit of a relationship in origin here. but it's not, in displacement and horsepower, but not that much. So we could, and year doesn't mean anything. So we could make a smaller scatter plot matrix that would be a little bit easier to read, and you could use that. Or, as I say, you can do the individual plots so that you get a really clear picture. It depends on the display. Okay, so thank you for your attention, and I look forward to having you accomplish a lot with homework 1.